The Pokémon Red and Blue cartridges you played as a kid, they were a lie.
They really were. A complete illusion.
Right. You know, you thought you were playing this finished, perfectly polished global phenomenon. You thought you were experiencing the definitive vision of a massive corporate juggernaut.
Which is exactly what they wanted you to think.
Exactly. But what you actually held in your hands was, it was basically a Frankenstein's monster. Just this stitched-together mess of patched code, spliced data, and like a hidden creature that even Nintendo's executives didn't know existed.
It's wild to think about now.
It really is. So, welcome to the deep dive. We are taking the noise of the day, shutting it out, and pulling up a chair for a late-night fireside intellectual chat.
Just a really relaxed, atmospheric look at the past.
Yeah. We are examining an enormous stack of sources tonight. Developer interviews, decompiled assembly code, localization notes, the works. And we're using all of it to look at the chaotic, unrefined, and brilliantly broken evolution of the Generation 1 Pokemon games.
The real digital archaeology of red, green, blue, and yellow.
But before we step into all that, I want to seamlessly weave in a quick mention of Decoding the Dark. We are incredibly grateful for your continued support, and if you enjoy this atmospheric space we've created, we'd love to ask you to like and subscribe to this audio cast. It really helps us keep the fire burning.
It absolutely does. And the digital archaeology we are diving into tonight is arguably one of the most fascinating development stories in the history of software.
Oh, without a doubt.
I mean, we are going to explore how severe hardware limitations on the original Game Boy, complex transnational localization hurdles, and literal catastrophic coding errors accidentally birthed the most legendary playground rumors of the 1990s.
The stuff we all whispered about at recess, right?
Exactly. We have to strip away the nostalgia of the multi-billion-dollar multimedia empire we know today.
Yeah.
We have to look at the raw, volatile reality of a small group of programmers who were just pushed to their absolute limits.
Which means we need to turn the clock back to the very beginning,
Sure.
early 1996. Because to understand the polished phenomenon the Western world saw in 1998, we have to look at the chaotic foundation built in Japan.
Right, the true genesis of the whole thing.
Yeah. So February 27th, 1996, Game Freak releases Pocket Monsters Red and Green in Japan. And the aesthetic alone is a shock to anyone who grew up with the global versions.
Oh, completely. It's night and day.
If you picture these original cartridges, you are likely imagining those iconic, slightly translucent red and blue plastic shells. You know, the ones that felt like little futuristic artifacts.
I remember just staring at them. They look so cool.
But they weren't like that at all originally. The Japanese red and green releases were just standard, utilitarian, gray Game Boy cartridges.
The physical presentation was entirely unassuming. Just boring gray plastic.
Gray.
And honestly, that unassuming exterior was the perfect metaphor for the structural reality of the code contained within it. When we look at the decompiled code and the raw assets of those original Japanese red and green versions, the sheer graphical instability is it's the first thing that jumps out at you.
Oh, the sprites, the two-dimensional pixel art that represented the creatures in battle.
Yes, they were incredibly unrefined. Many of them barely resemble the characters we know today.
They're famously hideous. I mean, there is that legendary example involving Mew, the mythical 151st Pokemon.
The hump.
Yes, the hump. If you look at Mew's original sprite in the Japanese games, it looks slightly sickly, and it has this strange, highly visible, misshapen hump on its head.
It looks almost fetal. It's really strange.
Right. And from the sources, the reason for this is entirely logistical. The programmers who were tasked with creating these in-game battle sprites were drawing them without having Ken Sugimori's finalized official artwork on hand.
They were essentially flying blind. Just
How did
guessing.
they even do that?
Well, you have to remember the context of Game Freak at this time. They weren't a massive veteran studio. They actually started out as a self-published video game fanzine in the 1980s.
Wait, really? A fanzine?
Yeah, a literal magazine they printed themselves before transitioning into game development. And by the time they were finishing Red and Green, they had been grinding through this grueling 6-year development cycle.
6 years is a lifetime in 90s game development.
It is. They were repeatedly on the brink of bankruptcy. Satoshi Tajiri, the creator, wasn't taking a salary for extended periods. He was living off his parents.
Oh, wow. I had no idea it was that dire.
Very dire.
Yeah.
So when it came to the art, the pixel artists were interpreting rough concept sketches under extreme hardware limitations. They were trying to compress these complex creatures into tiny grids of black, white, and 2 shades of gray.
It's like trying to build a complex architectural structure while the foundation is actively sinking, and you don't even have the final blueprints. You're just guessing where the load-bearing walls are supposed to go. And that instability, it wasn't just visual, it was deeply mechanically structural. We really have to talk about the imbalances in red and green.
The psychic-type monopoly.
Yes, because the psychic-type Pokemon weren't just strong, they were completely, undeniably broken.
The whole rock, paper, scissors mechanic of the elemental types is the core of the combat system, right?
Yeah.
There are 15 elemental types in Generation 1, creating this massive matrix of strengths and weaknesses.
But the balance was totally skewed. Psychic-type Pokemon had extremely high special stats.
Right, and in Generation 1, the special stat functioned as both their magical attack power and their magical defense power simultaneously.
Which is wild. So if you use a move like Amnesia, it doubles your attack and your defense in one turn. That alone made them formidable. But the true issue was the lack of counters.
The predators that were supposed to keep them in check.
Right. Bug-type and Ghost-type attacks were intended to be their natural predators. But the Bug-type moves were practically useless. Out of the entire game, there were only 3 damage-dealing bug moves.
Let me guess. Leech Life, Pin Missile, and Twine Needle.
Exactly. And their base power was laughably weak. Plus, the strongest bug-type Pokemon you could find were things like Beedrill or Parasect.
Which had terrible stats and were weak to practically everything else in the game.
Exactly. So that leaves the Ghosts. Ghost-type attacks were designed to be the ultimate weakness, the Achilles heel for psychic Pokemon.
Intended to be, yes, but they weren't.
Because of a bug.
Because of a literal oversight in the game's code. Psychic Pokemon were accidentally rendered completely immune to Ghost-type attacks.
How does that even happen?
Well, the game's memory contains a lookup table. It's basically a grid that dictates type effectiveness. When the game calculates damage, it checks this table. If a water move hits a fire Pokemon, the table says, okay, multiply damage by 2.0.
Right, double damage. Super effective.
Exactly.
Yeah.
For Ghost attacks hitting Psychic Pokemon, the intended multiplier was 2.0. But the value entered into the table was a 0.
I have to stop you there, because the poetry of that specific bug is just incredible to me.
It really is.
The literal ghosts in the game. These spectral, supernatural entities that were supposed to be terrifying, they were rendered completely powerless by a literal ghost in the machine.
A rogue 0 in the code.
A digital phantom just stripped them of their entire purpose. It's an accidental masterpiece of irony. But, it also means that the combat system was fundamentally shattered on a competitive level.
It was shattered. I mean, the resulting product functioned much more like a beta release or a late-stage prototype than a finished, globally ready commercial product.
Yeah.
They were inventing a complex battle system with hundreds of variables, hundreds of moves, and thousands of stats. And all of it was crammed into a cartridge that had roughly 512 kilobytes of ROM.
512 kilobytes, that is nothing.
To put that in perspective for you, a single high-resolution photograph on your smartphone today takes up about 10 times more space than the entirety of Pokémon Red.
That is staggering.
So they were making compromises every single level of the architecture just to get the game to boot up without crashing.
So we have this brilliant but chaotic first draft. It's bursting with charm, the core loop of catching and battling is incredibly addictive, but the foundation is cracked.
Deeply cracked. There are typos in the code, the art is rough, and the balance is non-existent.
And then the game explodes in popularity in Japan. It becomes a massive hit. And Game Freak realizes they have a massive problem. They want to bring this phenomenon to the rest of the world.
But they can't.
Right. They literally cannot just translate the text of red and green and ship it to America and Europe. The code was too fragile. It just wouldn't survive the localization process.
And that realization is the catalyst for what we could call the Blue Rescue.
The Blue Rescue. I like that.
Yeah. In late 1996, Game Freak released a third version in Japan, Pokémonsters Blue. Initially, it was only available through a special mail-in offer for subscribers of the CoroCoro comic magazine, though it hit retail later.
Right.
And this wasn't just a director's cut with some bonus features. This was a massive, fundamental structural overhaul of the game's engine from the ground up.
They brought in the heavy machinery, they went back to the drawing board and fixed those unrefined sprites. They finally replaced the weird, lumpy artwork with the polished, finalized Ken Sugimori designs that the rest of the world would eventually recognize.
Yeah, no more fetal Mew.
Exactly. And they updated the underlying scripts, smoothed out the dialogue flags, and executed major map redesigns.
Map redesigns offer a perfect window into the refinement process, actually. Consider Cerulean Cave.
That's the massive endgame dungeon where you find Mewtwo, right?
Exactly. In the original Red and Green, the layout of that cave was chaotic. It was labyrinthine, unnecessarily frustrating, and computationally messy. The way the tile sets overlapped actually caused memory lag on the Game Boy processor.
Oh, it physically slowed the game down.
Yes. So when they built Japanese Blue, they completely altered the layout, they streamlined the pathing algorithms, made the dungeon flow logically, and optimized the memory usage of the map tiles.
And they also tweaked the social mechanics. Japanese Blue introduced new in-game trades with non-player characters. Suddenly, a solo player could trade a specific Pokémon to a computer-controlled character to obtain things like Haunter and Kadabra.
Right.
Because in Red and Green, getting the final evolutions of those specific Pokémon strictly required you to use a physical game link cable to trade with another human being.
That is a crucial detail, because it sets up the genius of the international release strategy. So to recap the timeline, Japan now has 3 games: the buggy, original Red and Green, and the highly polished, stable, upgraded Blue version.
Okay, so Nintendo America now has the task of bringing this franchise to the West.
Yes.
And this is where the Frankenstein analogy really comes to life. Because Nintendo didn't just translate Japanese Blue, they engaged in this bizarre process of transnational hybridization.
An organ transplant, basically.
Exactly. For the Western release of Pokémon Red and Blue, they took the stable nervous system, the polished graphics, the optimized map layouts, and the stable engine of Japanese Blue. But then, they forcefully spliced that engine with the encounter tables and the version-exclusive Pokémon lists from the original Japanese Red and Green.
It's a fascinating approach to localization.
It's so weird.
It is, but it makes sense when you look at it. Encounter tables dictate which wild Pokémon appear in which patches of grass. By splicing the data this way, Western players got the visual polish and the crash-resistant stability of Blue, but they inherited the exact ecological distribution of the original Japanese Red and Green.
So if you bought the Western Pokémon Red cartridge, the game ran on the Blue engine, but it pointed to the encounter tables of Japanese Red. This meant you could catch version exclusives like Ekans and Oddish.
Correct. And if you got Western Pokémon Blue, you were running the Japanese Blue engine, but your game was pointing to the encounter tables of Japanese Green, meaning you could catch Sandshrew and Meowth.
Okay, wait. I have to push back on the corporate logic here.
Sure, go ahead.
Why go through this incredibly complex surgical process of splicing data? Why didn't Nintendo of America just take Japanese Blue, which was already the most stable, polished, definitive product translated, and release it as a single game called Pokémon in the West?
It's a fair question.
Was splitting the game into Red and Blue in America purely a cynical psychological trick to sell more Game Link cables and force kids to buy 2 cartridges?
It's easy to view it cynically, yes, but it actually speaks to the fundamental philosophy of the franchise's creator. Satoshi Tajiri designed Pokémon primarily around the concept of social exchange.
The trading.
Exactly. The Game Link cable wasn't a post-development afterthought. It was the genesis of the entire project. Tajiri has stated that the initial spark for the game came from imagining insects crawling back and forth through the wire, connecting 2 Game Boys.
That's a great image. By
maintaining the version-exclusive encounters from Red and Green, but grafting them onto Blue's stable engine, Nintendo brilliantly preserved that dual version marketing incentive.
So they preserved the friction, but removed the frustration.
That's a great way to put it.
They maintained the social mandate. You literally could not complete the game, you could not catch them all, without finding a human being who owned the opposite color cartridge and physically connecting your devices. But they ensured the game wouldn't crash while you were doing it.
It's actually a masterclass in behavioral product design.
It really is. And speaking of the colors, let's quickly debunk a very persistent internet myth. There is a long-standing rumor that the West got Red and Blue instead of Red and Green as a patriotic nod to the colors of the American flag.
Yes, that rumor has circulated for decades. But from a marketing and design perspective, it holds no water.
Right.
The shift from green to blue in the West was far more likely about establishing an immediate, universally understood elemental dichotomy.
Right. I mean, on the cover of Red, you have Charizard. a massive, terrifying fire dragon. On the cover of Blue, you have Blastoise, a massive water turtle with literal cannons protruding from its shell.
Fire versus water.
Exactly. It's an elemental conflict that every kid on the planet instantly understands. Fire versus a plant dinosaur like Venusaur, the mascot of green, just doesn't have the same immediate, diametrically opposed, visceral impact.
It's a brilliant use of visual shorthand. Red and blue are the most diametrically opposed primary colors in human psychology.
Oh, interesting.
Yeah. When you put them next to each other on a store shelf, it immediately communicates the concept of a rivalry. It primes the consumer for the dual version trading and battling mechanic before they even pick up the box.
That makes perfect sense. But as we look at how this Japanese DNA was spliced into the Western cartridges, we have to recognize that it didn't just require code changes.
No, it was much deeper than that.
It required profound cultural, linguistic, and even medical translations. And as we transition from the raw code to the strange world of cultural censorship, I want to gently remind you, our listener, to check out Decoding the Dark. Thank you for sharing your time with us for this exploration of retro gaming history. It's your curiosity that makes these deep dives possible.
Let's delve into those localization hurdles because they are incredibly revealing.
You really are.
When you translate a piece of media from Japanese to English, you aren't just swapping vocabulary. You are actively translating cultural norms.
Right.
The localization team at Nintendo of America was relatively small, and they had to adapt a deeply Japanese game for a Western audience that was highly sensitive to what was appropriate for children in the 90s.
And the examples of this are just fantastic. Take the old man in Viridian City. Very early in the game, you try to walk north, and an old man is blocking your path, forcing you to stay in the town.
Everyone remembers that guy.
Right. In the original Japanese script, the context for this is that the man is heavily intoxicated. He is drunk, and he has passed out in the middle of the road.
Which is pretty intense for a kid's game.
Yeah.
So the localized Western version softens this significantly. The translators completely remove the alcohol reference, and instead, the man's grandson apologizes, saying the old man just hasn't had his coffee yet and is being incredibly grumpy and stubborn.
Which is honestly a very relatable reason to lie down in the middle of the street.
It is.
And there's another great one. Deep in the game, there is a hiker NPC who is just laughing uncontrollably. When you speak to him in the Japanese release, he explicitly states that his hilarity is the direct result of eating a suspicious mushroom he found in the wild.
Again, the localizers had to erase what looked like an accidental reference to hallucinogenic drugs.
Right, you can't have kids talking to a guy tripping on shrooms.
Exactly. So in the English release, the hiker simply claims he is laughing because he has severe hay fever and his allergies are acting up.
Which makes no sense, but it passes the censors.
Exactly. And we see a similar, though perhaps more structurally significant, shift in Celadon City at the game corner.
The casino?
Precisely. It is functionally a casino where you play slot machines. The sign outside originally read, "Coins into prizes," which carried a heavy, direct connotation of gambling and cash-like payouts.
Yeah, that's literal gambling.
So the English localizers shifted the phrasing to "coins exchanged for prizes." It seems like a minor semantic difference, but it was designed to soften the gambling aspect, framing it more like a Chuck E. Cheese arcade redemption counter than a Las Vegas casino floor. They were actively navigating the moral landscape of the West.
But the hurdles weren't just moral or cultural, they were deeply physically restrictive within the game's memory. This is where the hardware limitations come roaring back into the picture because English words take up significantly more digital space on a cartridge than Japanese characters.
Yes, this is a fundamental issue of text encoding. The Japanese games primarily used a custom encoding based on Shift-JIS or similar formats. In those systems, complex concepts can be conveyed in just 2 or 3 kana or kanji characters.
Right.
A single character might represent an entire word or concept. But in English, utilizing an ASCII-style system, every single letter is a separate byte of data. To spell out a word like potion, you need 6 bytes. To spell it in Japanese, you might need 2.
And the Game Boy only has an 8 kilobyte video RAM. It builds the screen using an inevitable grid of tiny tiles. If your English text requires 3 times as many letters, you need 3 times as many tiles just to display a simple sentence.
It adds up fast.
This physical space limitation literally forced the developers into corners. They had to restructure the actual gameplay mechanics just to fit the English alphabet.
The most glaring example of this is the PC box capacity.
Yeah.
In the Pokemon storage system, you deposit creatures you aren't currently using.
Bill's PC.
Yes, Bill's PC. In the Japanese versions, the PC system was divided into 8 boxes, and each box held 30 Pokémon. But because Western text required more memory allocation for the interface and the longer English names, they had to restructure the save file architecture.
Because the battery save memory was full.
Right. The SRAM, the battery-backed save memory, only had so much space. To accommodate the larger English strings, they reduced the box capacity from 30 to 20 and increased the number of boxes to 12.
The total capacity is exactly the same, 240 Pokémon, but the entire architectural layout of the memory banks had to shift just because the English alphabet is greedy with space.
Exactly.
You also see this on the town map. The English names for cities, like Cerulean City or Vermilion City, were literally too long to fit in the designated UI space on the screen.
So the localizers had to drop the words city and town entirely from the map labels. It just says Cerulean or Lavender.
And when you are dealing with a text-heavy RPG and a small localization team, these linguistic pressures breed some incredible errors.
The Spanish localization is particularly infamous for this.
Oh, it's so good.
The translators were clearly working from spreadsheets of text without always having the visual context of the game in front of them. When referring to the Pokemon Squirtle retreating into its tortoise shell, the Spanish translators used the word concha,
which specifically translates to a seashell, like you'd find on a beach, rather than a turtle's carapace.
Right.
But my absolute favorite Spanish translation error happens when you go fishing. When you cast a line and hook a Pokemon, the intended English message is something like, "The hooked Pokemon attacked."
But the translators seemingly confused the word hooked with something being crooked or wicked.
Yes, so the Spanish version translated it to El malvado Pokemon atacó, which literally means the wicked, evil Pokemon attacked. You're just trying to catch a helpless little Magikarp, and the game is dramatically announcing it as an entity of pure malice.
It's delightful. But beyond the text, the localization process also required profound mechanical and safety changes. And the most significant of these revolves around a massive, real-world medical crisis.
The anime incident.
Yes. In December 1997, the Pokemon anime was airing in Japan. Episode 38, known as the Electric Soldier Porygon episode, featured a sequence with high-speed, alternating red and blue flashing lights.
The strobe effect, it was flashing at something like 12 hertz, right? A frequency perfectly calibrated to overload the visual cortex.
Exactly. The animation triggered photosensitive epileptic seizures in hundreds of Japanese children simultaneously.
That is terrifying.
It was a terrifying, unprecedented event. It made global news, the anime was pulled from the air for months, and Nintendo stock took a hit. It was a crisis that threatened the survival of the entire franchise, just as it was preparing to launch globally.
So Nintendo of America realizes they are about to release a video game into a market where parents are already terrified that Pokemon causes seizures. They had to take aggressive, proactive measures.
They did. The localizers literally had to go into the game's assembly code and manually tone down the high-speed flashing animations of specific combat moves.
Moves like Thunderbolt and Hyper Beam.
Exactly, and Blizzard too. In the Japanese versions, these attacks featured rapid, intense screen flashes. The Western localization team went in and fundamentally altered the rendering routines, reducing the frequency of the flashes and altering the color palettes to ensure the game met rigorous new safety standards. They had to ensure it wouldn't trigger a panic in the West.
And while they were tinkering under the hood, they also made mechanical balance tweaks. They nerfed the move Blizzard.
Oh, yes.
In the original Japanese releases, Blizzard had a massive, frankly unfair 30% chance to completely freeze the opponent solid, which was basically a death sentence in Generation 1.
If you got frozen, you were done.
Right. In the Western releases, they altered the random number generation thresholds, dropping that freeze chance down to a much more balanced 10%.
The localization process was incredibly invasive. They weren't just translating a book. They were performing an organ transplant, as you said earlier, while simultaneously trying to rewrite the DNA of the organs they were moving.
Okay, but this brings up a terrifying question about the domino effect of altering code. Because if you mess with the DNA, sometimes you create mutations.
You definitely do.
You mentioned they were fixing things. I want to know how fixing one thing completely broke something unrelated. Tell me about the substitute and swift bug. How does a localization team accidentally make health-draining moves like absorb and Dream Eater hit through defensive shields?
That is perhaps the most elegant illustration of how fragile the game's logic was.
Yeah.
In the original Japanese games, there was a move called Swift. Swift's entire gimmick is that it has a 100% accuracy rate. It is mathematically designed to never miss.
Right, it always hits.
However, the Japanese games had a bug. If the opposing Pokémon used a move called Substitute, which creates a physical decoy doll on the field to absorb damage, Swift would occasionally miss the decoy.
Which defeats the entire purpose of the move, Swift.
Exactly. So the Western localizers, trying to be diligent, went into the code to fix this. They found the accuracy calculation routine and added a specific flag, a bit of code that says, if this flag is active, bypass the accuracy check.
Makes sense so far.
They wanted to apply this flag to Swift when it interacted with Substitute, but they made a critical error in scope. They didn't apply the flag locally to the specific index number for the move Swift. They applied the flag globally to a specific class of damage interactions.
So they cast too wide a net.
Yes. Due to how the memory addresses were clustered, this specific accuracy bypass flag inadvertently spilled over and altered the code for HP draining moves. Moves like Absorb, Mega Drain, and Dream Eater.
Wow.
By trying to fix Swift, they accidentally granted all health draining moves the completely unintended ability to entirely bypass the substitute doll and drain health directly from the hidden Pokemon.
It perfectly highlights how interconnected the architecture was. You pull one string to fix a knot, and the entire sweater starts to unravel, which is the perfect pivot. Because despite all this meticulous patching, the translation, the cultural scrubbing, and the safety modifications, the memory limitations of the Game Boy meant these games were holding together by a microscopic thread.
A very, very thin thread.
And the friction of that thread snapping created the most famous playground rumor digital anomalies in the history of gaming. Let's talk about the glitches.
We have to begin with the Japanese select glitch, because it sets the stage for everything that follows.
Okay, set the stage.
In the original Japanese versions, there was a fatal, fundamental flaw in how the game managed your inventory cursor. When you opened your item bag and pressed the select button to highlight an item, let's say the 14th item in your bag, the game had to remember what you highlighted.
Right.
So it wrote that item's position to a specific memory address in the RAM, specifically address CC35.
CC35, the magic coordinate.
The magic coordinate.
Yeah.
Now, basic programming hygiene dictates that when you close the bag, the game should clear that memory address, resetting it to 0.
Just flushing the cache, basically.
Right. But the developers forgot to include the instruction to clear the buffer. So if you exited the bag, the game's active memory still stubbornly remembered that you had the 14th slot selected.
It's just sitting there, holding that variable, waiting for an instruction.
Yes. And if you then walked into the tall grass, entered a battle, and opened your Pokemon Party menu, you could press a button and the game would execute a swap command.
Okay.
But because address CC35 was still active, it didn't swap 2 Pokemon. It swapped the hexadecimal data of your 14th item with the hexadecimal data of a living creature in your party.
Wait, I need to make sure I'm understanding the sheer scale of this brokenness. You are taking an inanimate object in a list, like a potion or a bicycle or a nugget, and you are mathematically swapping its identity with a Pokemon in the game's memory bank.
That is precisely what is happening. The item array and the Pokemon data array are just contiguous blocks of memory. By doing this, players were able to write out-of-bounds data directly into the game's active RAM.
That's arbitrary code execution.
Exactly. You could manipulate the quantity of an item, swap it, and instantly transform a useless Magikarp into a level 100 Mew.
Or you could execute the legendary Dekokashira door glitch.
Oh, that one is amazing.
If you manipulated the right memory addresses, you could corrupt the map's warp data. You could literally walk out the front door of your starting house in Pallet Town, and instead of stepping onto the grass, the corrupted memory pointer would drop you directly into the Hall of Fame credits sequence.
Bypassing the entire game.
Right, allowing you to beat the entire game in under 3 minutes without ever fighting a single battle.
It allows the player to become the programmer. They are rewriting the rules of the universe from within the universe. Now, that specific memory leak with the select button was identified and patched out of the Western releases. The Blue Engine fixed it.
Good for them.
But because the Western releases underwent that massive localization surgery, they got their own completely unique legendary anomaly, the Old Man glitch, which leads directly to MissingNo.
MissingNo, the pixelated barcode-looking block of static that haunted our childhoods. And what's wild is that Japanese players never experienced MissingNo in this way. MissingNo is a purely Western phenomenon.
It is.
Because the localizers changed the old man's dialogue to remove the alcohol reference and altered his catching tutorial, they inadvertently created a massive memory leak.
Let's break down the logic of how the Game Boy handles memory for this. When the old man shows you how to catch a Weedle, the game enters a tutorial state. It needs to temporarily change your player character's sprite on the screen to the old man's sprite.
Right, so you look like him while he throws the ball.
To do this, it needs to free up some memory. So it temporarily takes your custom player name, the name you typed in at the start of the game, and stores it in the memory buffer that is usually reserved for generating the wild Pokemon encounters on whatever route you are currently standing on.
Okay, so if I name my character ASH, the game takes the digital letters A, S, and H and dumps them into the what wild Pokemon lives in this grass folder just to hold them for a minute.
Yes. Now, normally, this isn't a problem. When the tutorial ends and you walk out of the city onto a new route, the game updates that folder with the correct wild Pokemon data for that new area, overwriting your name.
But players discovered a loophole.
A massive loophole. If you use the move Fly to travel directly from the old man to Cinnabar Island, and then you use Surf to swim up and down the extreme eastern coastline of the island, there is a critical mapping error.
I remember this so vividly. That specific strip of water tiles on the right side of the island.
That specific strip of water was programmed by the developers with the attribute of being a valid encounter zone. The game knows that wild creatures can attack you there, but the developers completely forgot to assign any actual wild Pokemon encounter table to that specific zone.
Oh, this is brilliant. So the game triggers an encounter, it checks the folder to see what Pokemon is supposed to attack you. It sees that the folder hasn't been updated with any new data for Cinnabar Island, so it just reads whatever is currently sitting in the buffer, which is the player's name.
Exactly. The game reads the hexadecimal values of the letters in your name and tries to construct a biological entity out of them. The Game Boy uses a custom character encoding.
How does that work?
Well, the letter A might be hexadecimal value 80. The letter S might be 92. The game takes those numbers and looks at its internal index of valid Pokemon.
But the valid Pokemon only go up to index 151, right? Hexadecimal 80 translates to a decimal number of 128, which might be a valid Pokemon. Wait, no, the internal index is scrambled. But if it reads a letter that translates to a number higher than 151, the game panics.
It doesn't panic, it simply executes its failsafe. Because the number does not correspond to a valid Pokemon ID, the game generates a missing number handler. MissingNo.
Ah, missing number.
Right. It points to a blank spot in the ROM, pulling random garbage data to construct a visual sprite, resulting in that terrifying scrambled barcode block.
And the most famous side effect of encountering MissingNo, the infinite item duplication. Why does seeing this glitchy block of static suddenly give you 128 Master Balls in your backpack?
It comes down to how the game registers that you have seen a Pokemon for your Pokedex.
Okay.
The game keeps a bit array, a long string of ones and zeros, to track which of the 151 Pokemon you have encountered. When you encounter MissingNo, the game tries to update the scene flag for a Pokemon ID that is vastly larger than 151.
So it's looking for a box to check that doesn't exist.
Exactly. It calculates the memory offset for this massive ID, which pushes the data pointer completely out of the designated Pokedex RAM area.
It overshoots the target.
It overshoots the target and lands directly inside the RAM area that manages your item inventory. Specifically, it lands on the byte that determines the quantity of whatever item happens to be sitting in the 6th slot of your bag.
Wow.
By trying to set the scene flag, it flips the highest bit of that quantity byte to a 1, which mathematically adds 128 to the item total.
It is the ultimate duplication glitch. Infinite rare candies, infinite nuggets, all because of how an 8-bit processor tried to remember your name while an old man drank his coffee.
It's the butterfly effect in code.
But the glitches don't stop with MissingNo. We have to talk about the Mew glitch, also known as the trainer fly glitch. Because unlike MissingNo, this mathematical exploit works in every single version of the game across the globe.
The Mew glitch is arguably a masterpiece of mathematical exploitation. It relies on a different memory address.
CD23.
CD23.
Okay.
In the game, certain enemy trainers have a line of sight that extends off screen. If you step into their line of sight, the game registers that a battle is about to begin.
But if you simultaneously press the start button the exact millisecond you step into their sight line, the menu pops up before the trainer can walk up to you. And from that menu, you can use a Pokemon with the move Fly or Teleport to escape the area.
Yes. And when you do this, the game holds a pending battle state in its memory. It knows it is supposed to trigger an encounter, but the player has vanished, so it enters a state of suspended animation waiting for the next trigger.
So the game is just holding its breath. And while it's holding its breath, you fly away and go fight a completely different trainer. Let's say you walk up Route 25 and fight the youngster who has a Slowpoke.
This is the crucial step. Every time you fight a Pokemon, the game stores that enemy Pokemon stats in active memory to calculate damage during the fight.
Okay, that makes sense.
When you defeat the youngster's Slowpoke, the game stores the Slowpoke's special stat in memory address CD23. And it just so happens that a level 17 Slowpoke has a special stat of 21.
So the number 21 is sitting in address CD23.
Yes. Now you fly back to the route where you originally escaped from the first trainer. The moment you enter the route, the game exhales. It finally triggers that pending battle state.
But because so much has happened, it is profoundly confused. It knows it needs to generate a wild encounter, but it doesn't know what species it's supposed to generate.
Because it lost the original data.
So it acts like a desperate student taking a test. It just looks at the nearest piece of paper. It pulls the data from memory address CD23 to determine the species of the wild encounter.
Exactly. And the data sitting in that address is the number 21 in decimal format. When the Game Boy converts the decimal number 21 into hexadecimal code, it becomes the value 15, specifically $15.
And if we look at the game's internal Pokédex index, Index 01 is Rhydon, Index 09 is Bulbasaur, and Index 15 is Mew.
A level 7 Mew appears out of thin air. You have manipulated the base stats of a random trainer's Slowpoke to mathematically summon a mythical creature.
It is absolute magic, and it gets even crazier. There is an extension to this trick called the level 100 underflow glitch.
Oh, the underflow.
Yes. If you use the stat-lowering move Growl 6 times on that Slowpoke before defeating it, you lower its attack modifier. The game, in its confused state, accidentally uses that modified attack variable to calculate the level of the glitched encounter. This drops the Mew's starting level from 7 down to level 1.
And here is where we encounter integer underflow, which is a classic quirk of computer science. The Pokemon games use complex algebraic curves to determine how many experience points a creature needs to level up. Mew belongs to the medium-slow growth group. The equation for this group is a cubic function.
I love that we are doing algebra right now.
It's essential to understanding the break. Due to a mathematical oversight in how that cubic equation was written, if you plug level 1 into the formula, the result is actually a negative number. It requires roughly negative 54 experience points to be level 1.
But the game normally never lets you catch a level 1 Pokemon, so it never mattered.
Exactly.
Okay.
Until the glitch allows you to catch one. If you take this level 1 Mew and send it into a battle where it gains, say, 20 experience points, its total experience is still below 0.
Right. Negative 34.
However, the Game Boy stores experience points as an unsigned 24-bit integer. Unsigned integers cannot process negative numbers.
They don't have a minus sign.
Right. So when the value drops below 0, the processor wraps around backwards, underflowing to the absolute maximum possible positive integer it can hold, which is over 16.7 million experience points.
Oh my god.
The game registers this massive number and instantly rockets Mew from level 1 straight to level 100 after a single battle.
It's astounding. When a tiny cartridge has almost 0 memory left, variables have to pull double duty. Attack modifiers determine levels, player names generate wild encounters. I mean, I want to ask a provocative question about all this.
Go ahead.
We look back at these glitches as charming, nostalgic quirks. But I honestly believe these broken elements actually ensured the franchise's survival. Without the playground rumors of Mew hiding under a truck or glitchy coastlines duplicating items, would Pokemon have achieved its mythical viral status in a pre-internet era?
It is a strong argument. The glitches were arguably essential to the cultural phenomenon.
I really think so.
In 1996 and 1998, gaming was still a largely solitary or highly localized experience. The existence of these incredibly deep, complex secrets created a word-of-mouth economy. It gave children social currency on the playground.
Exactly.
Knowing the convoluted specific steps to perform the new glitch was a form of tribal knowledge and social bonding. It transformed the game from a finite piece of software you beat and put away into an infinite, mysterious landscape that felt alive and unpredictable.
And speaking of that mystery, we have to mention Mew's actual origin. Because the most amazing part of the Mew glitch is that Nintendo didn't even know Mew was in the game.
They had no idea.
Shigeki Morimoto, a programmer at Game Freak, sneaked Mew into the code at the absolute last minute.
It was an incredible risk.
Yeah.
After the game had passed its final debugging phase, the developers removed the debugging tools from the code to finalize the ROM. Removing those tools freed up roughly 300 bytes of empty cartridge space.
300 bytes.
Morimoto, without Nintendo's knowledge or explicit permission, secretly programmed the data from you into those empty 300 bytes.
It was an act of pure developer rebellion. He just squeezed a mythical god into the digital margins of the game, and in doing so, accidentally birthed a legend that fueled the playground economy for a decade.
He really did.
But eventually, Game Freak had to rein in the chaos. After the wild, glitchy, culturally spliced phenomenon of Red and Blue, they needed to create a definitive, cohesive vision. And that vision needed to align with a new, unstoppable force, the television show.
This brings us to the maturation of the first generation. Released in Japan in 1998, and internationally a year later, Game Freak released Pokémon Yellow.
Yellow version.
Yes, and this wasn't just a patch to fix glitches. This was a radical reimagining of the core product.
The most obvious, striking change hits you right at the beginning. You don't get to choose between the iconic trio of Bulbasaur, Charmander, or Squirtle. You are given a Pikachu.
Just like the anime.
Right. And this Pikachu actively refuses to stay in its Pokeball. It physically follows your character sprite around the overworld map. It has a hidden happiness mechanic. If you turn around and interact with it, a little window pops up showing its mood.
And crucially, from a technical perspective, it features actual voice acting. Instead of a synthesized 8-bit chiptune screech that every other Pokemon used, Pikachu uses digitized audio of its anime voice actress, Ikugakani, shouting its name.
Which is a massive technological leap.
Right.
Putting clear, digitized PCM human voice samples onto a primitive Game Boy sound chip drains an unbelievable amount of cartridge space.
Yeah, it was a huge allocation of resources. But the integration of the anime didn't stop with the audio. The entire overarching plot is modified.
Oh yeah, your rival doesn't get a standard starter either. He gets an Eevee, mirroring the anime's narrative structure. And the game seamlessly integrates Team Rocket's Jesse and James into the villainous encounters, complete with their signature Arbok, Weezing, and Meowth.
It's amazing how heavily the anime influenced the source material. Yellow fundamentally shifted the core mechanics of the game. For the first time, a single player could obtain all three of the original starters, Bulbasaur, Charmander, and Squirtle, in a single playthrough by talking to NPCs, just like Ash Ketchum did in the show.
They also fixed learn sets that had baffled players for years. Charizard, a giant flying dragon with literal wings on its back, could finally learn the move Fly, which it couldn't do in Red and Blue.
They also actively rebalanced the difficulty curve to account for the narrative changes. Think about the first gym leader, Brock. He specializes in rock and ground type Pokemon. In Red and Blue, this was fine because you likely had a grass or water starter. But in Yellow, you are forced to start with Pikachu, an electric type whose attacks do literally 0 damage to ground types. It was mathematically impossible to win with just Pikachu.
So what did they do?
So the developers lowered the levels of Brock's Pokemon, and they populated the early routes with fighting-type Pokemon, like Mankey, giving the player a strategic out.
What we are witnessing with Pokémon Yellow is the first true multimedia synthesis in gaming history. Yellow wasn't a sequel. It was a video game actively reverse engineering itself to mimic a cartoon that was originally based on the game itself.
Ouroboros.
Exactly. The game spawned the anime, and then the anime turned around and dictated the reality of the game.
It is a remarkable feedback loop. However, beneath the surface of this fan service celebration, there was also a brilliant, somewhat devious business strategy at play.
Oh, I know where you're going with this.
Because you would naturally assume that the definitive edition of the game would contain all the Pokemon, making it the ultimate version to own.
But it doesn't. Yellow actually removed basic, incredibly common Pokemon from the encounter tables. You literally cannot find a Weedle or a Coughing or a Meowth anywhere in the wild in Pokemon Yellow.
By strategically removing those early game staples, Game Freak ensured that the social trading ecosystem remained completely intact. If you bought Yellow, you still absolutely needed to find someone with an older, glitch-ridden Red or Blue cartridge to complete your Pokedex.
It's a diabolical move. I liken it to a dealership selling you a brand new top-of-the-line luxury car, but intentionally removing the cup holders before they hand you the keys.
That's a great analogy.
They do it just so you are forced to keep your old beat-up sedan in the garage, specifically for coffee runs. It's brilliant. And Yellow also pushed hardware upgrades to drive sales. It supported the Game Boy printer, allowing you to physically print out your high score from the newly added Surfing Pikachu minigame.
And in the West, because it was released slightly later in the hardware lifecycle, it featured specific, enhanced color palettes designed to take advantage of the newly released Game Boy Color.
Yellow really represents the final maturation of the first generation. It took the unstable, visionary brilliance of the original Red and Green, the polished mechanics of Blue, the cultural feedback and localization adjustments of the global release, and the massive narrative weight of the anime, and fused them all into a single, cohesive experience.
It essentially closed the chapter on Generation 1 by establishing the precise blueprint for how Pokémon would exist as a multimedia empire for the next 3 decades.
Which brings us to the end of our journey tonight. We are gently wrapping up this deep dive, pulling you back out of the granular assembly code, stepping away from the hexadecimal addresses and the flashing pixels, and looking at the broader legacy of the franchise. And I want to leave you with a final, provocative thought to mull over.
In today's era of modern gaming, we live in a world of immediate and visible corrections. A game is released, and within hours, a massive day one patch is deployed over the internet. Server updates and auto-correcting code instantly erase any anomalies, smoothing over the rough edges before the vast majority of players even notice they exist. But looking back at the chaotic architecture of Generation 1, we have to ask, have we lost the magic of the glitch?
I think we have. Pokémon Generation 1 is revered today not despite its massive flaws, but because of them. The seams in the digital universe, the ability to swim on the edge of Cinnabar Island to summon a barcode monster, or the ability to manipulate memory addresses to walk through a wall into a glitched city, they gave players a profound sense of ownership.
It made the world feel truly yours.
Exactly. It made us feel like digital archaeologists, discovering real, unpredictable magic hidden deep in the code. We weren't just playing a sanitized, curated game. We were exploring an untamed frontier. And maybe, just maybe, that friction, that brokenness is something worth preserving.
It is a fascinating thought to carry with you. The idea that perfection might actually be less engaging than a beautiful mess.
Beautifully said. I want to give one final warm shout out to Decoding the Dark. Thank you, our listener, for spending your time diving deep with us tonight. We hope you found this journey into the hidden seams of digital history as intellectually stimulating as we did. Remember to like and subscribe, and we wish you a peaceful, curious rest of your day.